So hello guys, welcome to this new video. This video is regarding TLS on AWS LB, which I already have done a live stream, but the voice was not that good at that video, so I'm doing this video again. So what we're gonna do? We're gonna do the same thing. At first, we will create a self-signed certificate using OpenSSL. Then we will create a load balancer and upload the certificate on the load balancer and check using HTTPS. So with this, so let's start. We will talk a lot about what is TLS, how does it works, each and everything. So let's start. So what is TLS? TLS stand for Transport Layer Security. So what is a transport layer, you may ask? So transport layer is sits on layer 4 of WSI model. Now you may ask, what is a WSI model? WSI model is a standardized way of how data is transmitted between two systems or in a system, like this web page you are seeing, right? Whenever you click a button, how this data is transferred from this button to the binary code like 0 1, how does it transfer? So there is a 7 layers in OSI model. In layer 4 the transport layer sits. So transport layer is basically defines that in which protocol does a application takes to transfer the data. It may be TCP, it may be UDP. So transport layer security means that whatever data you are sending, it will go in an encrypted way, so that any man in the middle, or any interceptor, if they got the data, they will get a encrypted data, not actual data. Like this whole HTTPS is for that reason, like a TLS, transport layer security. Whatever data I am sending here or clicking a button, it will directly going to the Amazon web server, not any middle people can check. Or if they got the data, they will get a encrypted data. So we will implement the HTTPS using self-signed certificates. So there are two kind of certificates out there. One is mainly self-signed, another one is signed by certificate authority. Certificate, if you see this one, like let me click this one. See, there is a connection is secure. If you see the certificate, so it is common name is Amazon RSA, organization is Amazon. You can see the details over there. So this is from the Amazon. So they have signed their certificate. So I will do the self sign, not by any CA, because if you do by CA, they will I think they will charge something. They will not do it free. So without further, let's just start by creating a self signed certificate. How do we do that? So there is a library called OpenSSL, which is a free library. You can generate self signed certificate or any certificate CSR or any key files from that library. So I have my VM ready. Here I have my VM ready. I have created a folder called TLS. So that is already file I have created. So let me uh, remove. Let me create another folder here called TLS2, and so there is nothing. Okay. So now to create a self-signed certificate, you need to maintain the 3 steps. At first you need to generate a key pair or key file. Then you need to generate a CSR, certificate signing request, by using that key file. When you got a CSR, by using that CSR, you need to CSR and the key file, you need to self-sign it and get a CRT or certificate file. So we will use the OpenSSL library to create the whole thing. So to create a key file, you know, to type just OpenSSL gen RSA, which stands for generating RSA. So RSA is the algorithm to create or generate the key file. So OpenSSL gen RSA, then you need to out means the output file, the key file. So we will mention here the key file name. So I'm mentioning key file dot key. You can mention any name here, like abcd dot key, something like that. And you need to mention the size, like what bit size the algorithm will be used to generate the file. So the lowest size is I believe 1024, then 2048, 4096. I'll use 4096. You can use 2048 or 1024. So I'm using 4096 and hit enter. It will take some time to generate the key file, and it's done in a couple of seconds maybe. So this is the key file, if I cat this one, you'll say that begin private key. So this is the private key. You can generate a public key from this private key. This is the private key. It will be required when we will upload the certificate and the key file on the load balancer. Now, as we have a key file, we will generate a CSR, a certificate signing request. So what is a certificate signing request? So think about it is a document which states your organization, your department, your location, and which is registered on your domain or something like that, which is unique. Not unique exactly. Suppose you have a URL abcd.com, which is unique. So you can mention this one in this CSR, and we can provide this CSR to a certificate authority, and they will check, and if the every details is perfect, they will sign on behalf of you, and you can use that certificate over here to use the HTTPS. So we will create a CSR. CSR is very important. It's a document, as I said. It will require some details. To generate a CSR file, you need to use OpenSSL rec. You are requesting a new means you are requesting a rec means you are requesting a CSR, hyphen new means a new CSR. Then you need to provide the key means this private key file. So OpenSSL rec hyphen new hyphen key file. Then you need to mention the out, like where the output file will be. So I'm mentioning here csr file.csr. So like this is the naming convention. You can give any name which ends with .csr, and you need to just hit enter. So here it will ask a lot of details like country name. I'm giving IN India. Self governance Telangana. I'm in Hyderabad right now. So this one locality is organization name. I don't have anyone, so I'm giving just none. Organization unit name I'm giving as a developer. Common name. So common name server FQDN stands for fully qualified domain name. So if you have a website or a domain name purchased, you can mention that one, or otherwise you can mention a server public IP also. So I will mention a random website like subodipsite.com. This site is exist or not, I don't know. I'm just mentioning here. Remember one thing, whatever website name you mention, it must be a top level domain like .com or something ends with. So subodipsite.com I have mentioned here. Email address I will give this one. And then challenge password, I'm not giving anything. You may want to. Optional company name, nothing. And you can see there is a CSR file is generated. So if you cat the CSR file, I just misspelled this one. So here the certificate request is there. So this is the certificate request which inside the CSR file. And also the certificate request consists of all the details you mentioned earlier. So if you want to sign this, if you hand over this CSR file to a CA, you can hand over to, and they will check the details and signed on behalf of you. But we will do self-signed. So for self-signed, we will use OpenSSL X509, which is used to self-signing a request, a CSR file. So CSR file is there. So we will use OpenSSL X509. So this is used to self-signing, to create a self-signing certificate. This X509 stands for. And then we need to mention the in. In means what is the input file, the CSR file name we need to mention here. This is a file, and we need to also mention the out, like where the output will be. So this will be a certificate. So it's a CRT file. This is a CRT file. So now also we need to pass the key file, like when the certificate will generate, what are the signing key it will use to generate the certificate. So here we need to mention this rec. We are requesting, what we are requesting, a signing key, and then we need to mention the key file. So we have provided, so X509 is for self-signing request. We are passing the CSR file and out getting the output on a CRT file. Requesting a new, requesting the signing key, which is the key file.key. and we need to mention the days, like how many days this certificate will be valid. I'm mentioning 365 days, which is 1 year, and hitting enter. Certificate requires self signature. Okay, so now you can see there is a CRT. So if you cat this CRT file, you'll see that this is the certificate. So we got the certificate, right? Now we have we have created a self-signed certificate, which is in this cert.crt. Now what we need to do? At first, let's check what a Apache web server looks like in a port 80. So I believe Apache is running on this machine. Yeah, it's running. So we can get the public IP of this VM, which is this one. And if I open this one here, so by default it's takes port 80. So yeah, Apache 2 is running. So it's the by default web page of Apache 2 web server, or Ubuntu, you can say. This Apache 2 configuration you can see here. So now we need to configure a AWS load balancer at first. Then we will upload this thing over there, these certificates and private key and certificate over there. Let's go to this AWS. So before doing that AWS load balancer, we need to do some things called, like, let me go to the EC2. We need to create a target group. I will tell what target group is all about. So you can see this is the instance. If you click this one, you will see the instance here. It's running. Now we will go to, at first let's create the target group. So this is the load balancer. I will not create the load balancer right now. So what is a target group? Target group is, so load balancer, how does it work? So already created, so let me delete it. So target group, so how load balancer works is that load balancer got a public IP or a public domain name. If it got a public thing, public external load balancer got a public access over the internet access. So whenever you hit on the public IP of the load balancer or URL, it will transfer the traffic with couple of VMs. Load balancer stands for transferring the load between 1, 2, 3, 4, 5 VMs. Okay. So you group the VMs in a target group. Target group, you can, suppose you have 5 VMs running. So you can create a target group which consists of 5 VMs. Now the load balancer will transfer the traffic in between the target group, like 5 VMs, in a round robin algorithm. Okay. So we'll create a target group here by target group. Then we'll use instances. You can create like lambda function, IP address, lots of options out there, but we will create just the instance, giving here that TLS group. So protocol, which protocol all the VMs will be using. So suppose you have 5 VMs. If I mention 80, so each and every VM needs to be listening on port 80. Okay. Now then the my VPC name and protocol I'm using is HTTP1. Health check is by default I am giving here. I'm not configuring anything, and that's it. Let's just hit next, and you need to choose the VMs. I have only one VMs. I'll click this one, and you will see ports for the selected instance. So I am selecting this VM, which will be listening on port 80, which is listening right now, the Apache. So include as pending below, and create target group. I have only one VM, so one VM target group. Now target group is created. Now the second thing we need to do, we need to upload the certificates onto our ACM, Amazon Certificate Manager, to quickly get the certificate while creating a load balancer. So we'll go to that ACM, this one, Certificate Manager, and import a certificate. So we already have a certificate. We will import. So certificate body. So we need to mention the certificate. So we need to go this VM We clear the screen. This is the certificate body. We need to copy from here, not this one, from here to. So we need to paste the certificate body. Now the certificate private key. So why I am uploading here is that when we will create the AWS load balancer, then we will import the certificate from the ACM. We can directly paste there also. It will also upload in ACM from there. So we have uploaded certificate body and private key. So if you have a certificate like certificate authority signed certificate, you will get some certificate chain. So you can paste the chains of certificate here. So I don't have any chains because it's a self-signed. So I'm giving next. I'm not gonna tag anything. Setting next and import. Yeah. So this certificate is there. So this website is not valid by the way. So the certificate I have imported in ACM. Now I need to create a load balancer. Let's just go to the EC2, and you will find in the left side there is a load balancer section. So just hit the load balancer, and there is no such load balancer right now. So I need to create a. So if you feel that you always need to check this location. If you are not getting, suppose you have created a load balancer, you are not getting the load balancer here, you just select which location are you. So I'm in the same region. So create load balancer. So I will create a application load balancer. So just hit create. So name I'm giving is MyLB. It will be internet facing, not a internal. It's a internet facing. So this will be the VPC. So load balancer suggests you to choose two different availability zones subnets, which I already had. So this is one and this is one. So I have choose here my VPC and two different availability zone subnet, which is US East 1A and 1B. Security groups, I already have configured security groups in the VM, so I will use this one, using this default one. And listeners, so right now this listeners tells that in which port the load balancer will listen. As we have already created a self-signed certificate and we will use to get the HTTPS, we will not use the HTTP, we will use the HTTPS. Now select a target. We need to select a target group. So this is the target group which we have added, and inside this target group we have only one VM right now. So this is the listener HTTPS 443. The load balancer will listen and it will forward the traffic to this target group on port 80. Now here we need to do something. So this is the security policy. So in load balancer, the SSL offloading will happen whenever you uploading the certificate, the TLS certificate on a load balancer. So whatever request, HTTP request you are sending from your machine, it will go to the load balancer, and as there is, you have already uploading the certificate and private key, the HTTPS decryption will happen in the load balancer. So we need to upload the certificates over here. There is a lot of security policies out there, but I will choose the recommended or default one. So here you can import also. Here you can import also. If you hit import, you need to just mention private key and certificate body, which I already done. So we will import from ACM. From ACM, select a certificate. We already have a certificate, this one, and nothing much. All by defaults. We have selected certificates. We have selected the listener and target group. We have selected the VPC, and that's about it. Let's just create the load balancer. Yeah, so it will take some time to create the load balancer. So we'll wait for that time, and when it will be done, we'll check. Now, after 2 to 3 minutes, it will take some time. 2 to 3 minutes. After 2 to 3 minutes, this LB is ready. So you can see this is active. It's showing. So if you open the LB, you will see this DNS name, a record, Amazon AWS.com. So you can copy this link. So this link can be accessible from anywhere in the world, and also this link is used to access our load balancer. So if you copy this link and paste it in the browser, you will see something. Let's see what happens. Let me just paste here, hit enter. It will not load, it will show some error. Okay, yeah, can't reach this page because when we are pasting this link, it by default using port 80 on HTTP, but our load balancer is listening on port 443. What you need to do, you need to just mention HTTPS in front of it and hit enter. So you will see your connection is not private, it's showing something like that. So you just hit this advance. For the first time, you just need to hit the advance, continue to do this one, unsafe. Now here's the thing, you will see, okay, it's still showing not secure, but there are two major difference. Let me show you. Here are the public IP of my VM. I'm pasting side by side. So it's listening on port 80, which is HTTP, and this one is listening on port 443 HTTPS. You can say that both are showing not secure. Then what is the meaning of why it's showing? You need to understand. Let me click on here and go to this one. You will see there is a certificate, but for this one there is no such certificate, because there is no such certificate. It's HTTP. So now just go to this certificate and see what exactly the certificate tells. So website.com developer, these details we entered while creating the CSR, if you remember. Now then, why this HTTPS crossing sign it's showing? Now most modern browser, including Chrome, your Edge, your Mozilla, anything, they have a trusted certificate authority list. If you are using a self-signed certificate, it's good for development purpose, it's good for internal organization users purpose. It's not for a production or commercial purpose. So when you are using a self-signed certificate, which is not known by anyone other than you, the modern browser will throw this kind of error that the website is using a HTTPS, a certificate, which Chrome or any modern browser or anyone does not trust, does not know which certificate it's using. So that's why it's showing the error, but still it's a HTTPS connection. So that's how you set up a self-signed certificate on AWS LB. You can see the LB name, you can see the HTTPS. It's the HTTPS connection. It's showing not secure because nobody trusts it. Like no certificate authority. Those big companies like Cloudflare, Amazon, Google have like GTS, something like that. So they don't know that this certificate is good, but it's really encrypting the data or something like that. They don't know. So that's why it's throwing the error. So that's how you encrypt. That's how you implement a self-signed certificate on AWS load balancer. You can implement the same certificate and key on Apache also, like in your VM Apache configuration file also, in your Nginx also, here and there. But load balancer is the easiest way to do that, because already the load balancer is good. If you have 3-4 VMs, you don't need to implement each and every VM the TLS. You just implement the certificate offloading in load balancer and it will do the job. So that's about today's this video all about. If you have any queries, you can comment down or reach out to me. So thanks for watching. If you have any queries, you can just comment down. Okay.